Well, in the world is even me. Hello, welcome to Probability and Statistics 2. So, lovely, we are done with dealing with Poisson's distribution, binomial distribution, and then what again? Negative distributions and all that. Good. So the reason why we're doing all those things is to use our knowledge to fuse into what we are going to do it in, and you will love it. Alright? Good. So I welcome you to Mass Expert video tutorials, and then today we are going to study about inferential statistics. Inferential statistics. You will love it, trust me. And please don't forget to have your percentage point of your T distribution. Yeah, that's my own. If yours is not available, then you have to pause the video, screenshot my own, and go and do a photocopy of it. Alright, and I also have my area under the normal curve. Beautiful. I also have my area under a normal curve. So if you don't have it, you can pause the video, screenshot, and go and do a photocopy of it. Alright, so we will be using this T distribution and area under a normal curve as far as our journey through this course is concerned. Thank you very much. Welcome. So, yeah, once again. So let's go. So, all that we are going to do in this chapter is that, you see, you will learn an important techniques. So here you are going to get some important techniques of statistical inference to use sample statistics to estimate the value of an unknown population. The value of an unknown population. In fact, you will have it. You will have it. It's just like this. Let's assume that we are in a class of we have a class of 30 students here, and then we have to choose the probability that there is a black, or there is someone who is fair in color, or there is someone who is black in color. Then we get, let's say, 5/30. So if we get a probability, or let's say 7/30. So if we get a probability of 7/30, can we say that, first, bear in mind that I'm only basing my emphasis on one class, even though there is a whole school, but I'm basing my emphasis on what? One class. So since I'm having 7/30 to be my probability of getting someone who is black or fair in color here, does it mean that if that results can be applied to the whole school? No, it can't be that. I hope it's clear. So I won't be confidently to conclude my results that is going to be that. So there will be an inference in. In fact, you will have it. Let's journey through and see what we are going to get. So with this, that means that we have to get some interval. We have to get, even though we cannot be 100% sure, but we can get an interval that we can boldly say that this and that can happen due to a certain word alpha level that will be given to us. So let's continue with it. Alright, so now let's start with what you need. So let's see what you need here. Alright, the first thing that you need here is random sample. So you see the same idea that is coming here, because it's not your first time hearing random sample. random sample. 2. The second one you need here is, and you know that the random sample is what? The n. Alright. And the second one you need here is condition of binomial. Yeah. Here I need your knowledge in binomial distribution very, very, very well. Alright. So let me refresh your mind some more under the binomial distribution. So binomial distribution. Alright, so we have a fixed number of what? Of tracks. A fixed number of what? Tracks. And also, we know that a fixed number of tracks is represented by what? The x. Alright. It depends, okay? You can represent by anything, just that you know what you are using it for. Because the same thing is not applying to all the books. Alright, we can get trials. We can get trials. Okay, we know that the trials are independent. The trials are independent. Alright. The trials are what? Independent. We also know something about two outcomes. Two outcomes. And these two outcomes is what? Whether success or what? Failure. Alright, that's whether success or what? Failure. You also need to know that here the number of the random sample times, we know that the success is represented by what? P, right? And the failure is represented by what? Q. So when you multiply this by this, it should be greater than or equal to 5. Or n times q should be greater than or equal to what? 5. So these are the requirements that what you need here. These are the requirements that you need here. So that's that. Alright. Oh, sorry. Don't worry. You let's ignore this. Alright. Let's ignore it. Alright, so now that's what we have here. These are the requirements that you need to know under this section. So from here, let's move to point of what? The estimate. Point of what? Estimate. As I said, we can be sure to say that since we are having only black fair color in this class, it's applying to the whole school. So we are going to use that as our point of what? So let's see what point of estimate means. What point of estimate means. Alright, so now when we talk of point estimates, point estimates, what are we actually saying? Alright, so now when we talk of point estimate, what we are saying is that it's using a single value. You see, using a single value from a sample used to estimate used to estimate population parameter. Yeah, it should come from a sample. We can't consider the whole population. If you do that, it will be something tedious for you. You can't do that in probability. So it must come from what? A sample. Alright? So now when we talk of point estimate, what we are saying is that using a single value, underline a single value, using a single value from a sample, from a what? Sample. And you know all the sampling techniques. How you know that one already? Alright, that is the stratified and the others. Alright, so sample used to estimate a population what? Parameters. Alright, so that is what about point what? Point estimates. Good. So now, under this point of estimate, this is what you also need also. Alright, so there are some key things that we have to define here. Anytime we see P here, we are talking of population proportion of what? Success. Population proportion of what? Success. Take note, this is what? Population proportion of what? Success. I know you know that P is always the success, Q is always the failure, right? But here, you can see that we have P and P what? Hat. I'll use that word to identify it, so don't worry. So anytime you hear me saying P hat, I mean this. So this P is using it to represent the population proportion of what? Success. Then the P hat will be the sample under the what? Population. That's why I'm using the P hat. So that will be the sample proportion of what? Success. So what do you think? Let's say we have Q. What do you think Q will be? Population proportion of what? Failure. So, okay, so that would be population, write it. That would be population proportion of what? Failure. So having the Q hat is going to be sample proportion of what? Failure. Good. So we need to understand these things so that when I'm using it, you won't be confused with it. Good. Now, let's see how we get this P hat. Let's see how we get this P hat. So you see that in probability, you can't get something to be more than what? One. Alright. So the sample proportion of success will be equal to the number of trials over the sample size, which is what? N. If you make it N over S, you are going to get a number which will be more than even 1. Okay? Alright, so be careful with that. So this will be the successful one, trials. And this will be the number of what? The number of trials. So the number of trials, or the successful trials, over the number of what? Trials. Alright, so now, now that we have P hat, then you can see Q hat will be easy for us. Because we know that so we know that Q hat will be equal to 1 minus what? The P hat. Alright. And since this cannot be greater than 1, there is no way that you can get a result of a negative probability. There is no way that you can get a result of this to what? Negative. It's unless you don't do it well. Good. Alright, so let's be okay with this so that we can move on. Alright. So now let's look at something here. Let me add one more thing. Good, I love it. Now, so let's see what this P hat is going to be. The P hat is a point estimate. It's is a point estimate for P, because we cannot use the whole population, but we can use the sample of what? Or let me say, we cannot use all the proportion, but we can use the sample of what? Of the proportion, in order to what? To get our what we want. Alright. So the P hat is going to be, so P hat is a point what? Estimate for what? P. So that means that if this is a point estimate for P, then let's assume this. Let's assume that we are going to do a voter registration card or identification card. So there will be what? A biometric machine there for you to go and do your biometric. So if it's correct, if your identity is identified, that means that such name or such card is yours. Good. So let's say, so for voter card identification. So 280 tracks. Alright, so now the number of trials we perform is 280. But out of the 280, we only had 1, 2, 3 number of times, or 1, 2, 3 times in getting the correct what? Identification. So let's say that we are in a country, let's say Ghana, right? Good. Then we are performing a voter card identification. You can't be only in one region or one state to do a voter verification and get 1, 2, 3 times of correct identification for you to say that you are applying the same thing to the whole country. No, you can't do that. You can't apply it to the whole country. So what you can do is that you have to take a sample of what? It. Alright? So that is the sample proportion. So that would be the P hat, which is equal to the X over the what? The N. So having this, the number of trials will be the N. So N is 230. Then the S will be the what? The number of what? Success. The number of what? Success in a successful trial. So that will be that. 1, 2, 3. So in getting this, it's going to be 1, 2, 3 over 230. And when you do that, you are going to get 0.44. You see, in probability, you cannot get a number which is more than what? 1. Good. So now, your interpretation there is that, you see, here you have no idea or accurate the point estimate is. You have no idea or how accurate this point estimate is. So you cannot say that you are using this point estimate to conclude for the whole country. No, it can't be that. That is why we use a confidence interval. So even though this is the point estimate, but how sure are we that this can be applied to for the whole population? It can't be that. It can't be that. good. So that is why we need confidence what? Interval. So let's go to confidence interval and you will have it. Alright, so now our next thing to look at is the confidence what? Interval. Because we are saying that the sample proportion that we have, which is the p hat, we cannot use that to estimate for the whole what? Proportion. That population. That means that we need, that's why we need the interval. So looking at the confidence interval, it's a range of numbers used to estimate a population what? Parameters. Alright? When we talk of alright, so now this means that the ending point and the what? And the starting point. Alright, that is what? A population what? A parameter. Right? Okay. So a range of numbers used to estimate a population what? Parameters. Good. So this range includes some things that you need in order for you to get it. Alright, so for the purpose of understanding, let me take you through. You know some of it already, but let me still take you through in order to remind you back. Okay? Alright, so the first one is the confidence what? Level. Please, the confidence level is not the same as the confidence what? Interval. So the confidence level is how confident you are that the actual value of the population parameters will be inside the what? The interval. So the confidence level is like this. I can't be, okay, you don't worry, you will get it. So the confidence level is how confident you are. How confident you are that the actual value, which is the what? The point estimate of the population parameter will be inside of the what? Of the interval. So we are going to use alpha to represent the confidence what? Level. Alright. So anytime you are using alpha, that is the alpha level. That is the confidence what? Level. And always 1 minus that will give you the other. Okay, so these are the most commonly used. The most commonly used. When you check most questions, the most common alpha level they use is this. Okay, and that's what I would like to let you know so that it will help you in your workings. Alright, you can get 80% though, you can get 70%. I'm not saying that it's always this, but this is mostly what most questions use. Alright, in fact, even in newspapers and all that, that's what they use. Okay, so 90% is the same as 0.90. Alright, and the alpha level is 0.10. You see, with this, when you add this to this, then you get what? 1. Alright, good. And you know 1 is the same as what? 100%. That is when you take it to percentage. Alright, so the alpha level for this is that, the alpha level for this is that. Alright, not all the cases that this will be given to you. There are some cases this will be given to you, but know that this is the same as this. And when this is given to you, know that it's the same as what? That. Alright. Knowing this, then we have to go for the critical what? Level. The critical what? Level. And you will have it. Alright. Alright, so now the critical level. The critical level. Alright, so we are still on the confidence interval. What is under the confidence interval? So what we are looking now is the critical what? Level. So a critical level is just simple. It's just a z-score that you know. That's how you find z-score. That's what you know. So it's a z-score that separates what? Sorry? That separates the likely region from the unlikely what? Region. So the z-score will help you in order to identify the likely part and the what? The unlikely what? Part. So in dealing with the confidence interval, it will help us to know the what? How much confidence we are, or the interval that we are being what? Confident. Alright. So looking at what we have here. looking at what we have here, this part, this middle part is the confidence what? Level. So that is the confidence what? Level. So, okay, I'll explain it much when we get to this side. Alright. So, that is the confidence level. But don't forget, if alpha is given to you, let's say the alpha is equal to A. I don't want to be specific for now because of this. So let's say if the alpha is A, know that here your confidence level is going to be within what? Interval. It's not going to be like left skewed or sorry, skew left or skew right. No, it's going to be within an what? Interval. So if it's going to be within an interval, that means that the z-score that we are going to have here and here, okay, let me say the area or the alpha that we are giving. So the area that we are giving is the outsiders, right? That is the here and here. So that is the area within this and this. No, so the alpha you are giving is not only the area here and it's not only the area here, but it's the area within here and here, the outsiders. Alright, that is the unlikely what? Part. Good. So in order for you to get the z-scores, right, then you see that you cannot just use all the alphas here. What you have to do is that you have to divide the alpha by what? 2. So you divide the alpha by 2 so that you get this part. Then you divide the alpha by 2, then you get this part. So this will be the negative part and this will be the what? The positive what? Part. But the area here and the area here should be what? The same. And not the same as what you are giving in the alpha giving you, but the alpha divided by what? 2. So let's come back to this. Alright, so here we are 95% sure. So you see where the confidence interval is. Sorry, the confidence level. Here we are 95% what? Sure. So if you are 95% sure, you know 95% is the same as 0.90, right? So that means your alpha level would be what? 0.10. That will be your alpha level. So you just take your calculator. So in order for you to determine your z-scores here, you can't determine the z-score for 0.10 to write it here. Please listen with a listening word. You can't do that to write all of them here. But when you do that, it means that you are ignoring this side. Okay? So you divide 0.10 divided by 2. And that will give you 0.05. That means that here we'll get a share of 0.05 and here you will get a share of 0.05. And when you add these two, it gives you the 0.10. Beautiful. So to determine the z here, to determine the z-score here, you know how to determine the z-score already. So you do that. So you use 0.05 in getting your z-score. Alright. The same thing applies to here. This is the same as 0.95. Alright. So the alpha level here is 0.05. Is that also? Then you divide this 0.05 into what? 2 equal parts in order to get this side and this side. Then you do that for that. So anytime you have a percentage of 90%, your alpha level is this, and this is going to be your z-score. This is going to be your z-score. You know how to determine it already. Alright. And with this one too, this is going to be your z-score, and with this one too, the same thing. So let me give it to you in the table form so that you know what I'm talking about. So it's the same thing. Here too is 0.98, right? So divide that alpha by 2 and you get that. Good. Alright. So now let's look at the common confidence level. and its critical value. So if you have 90% or alpha level of 0.10, your critical value is going to be Z alpha over 2, which is 1.645. So that is what you're going to write here. Then you negate it to represent it here. Good. So if you have 95% or alpha level of 0.05, the Z alpha over 2 is going to be equal to 1.96. Beautiful. If you have 99%, you know it can be 100%. Alpha level of 0.01. Alright, so Z alpha over 2 is going to be 2.575. Good, beautiful. So please, even if you don't know how to find these scores, with partaking in dealing with these questions, these are the ones which are commonly used. You can get 80 degrees, you can get any of it, but this is how we do it. Alright? So now you can see that if your confidence level is low, your your critical value too is what? Is least. See the higher confidence level, which is 99%. Look at our Z score, 2 points. You see how it is? Alright, so this is how it is, and I'll be back. Alright, so now, since we can use our point estimates to estimate for the whole population, and we are going to be a confidence level sure within a certain interval, then error will come in. Yeah, surely then the error will come in. So that is called the margin of what? Error. So the margin of error is where you take your critical value and use to estimate the point what? Estimate. And use to estimate the point estimate. That is when the margin of error will come in. So let's see the maximum difference between the P hat and the P. And it's N, not alpha, you know, it's NP. Alright, so this is a formula we use to calculate the margin what? Error. So this is the alpha over 2. So this is the P hat times the Q hat. All this over what? N. Bear in mind that this square root is affecting the N here also. Okay, so now let me take you through the steps in finding the margin of what? Error. Steps 1. So the first step is that first you need to find B hat, Q hat, and N. You need to identify them. Alright. 2. You will use the confidence level to find Z alpha over 2. That is the what? The confidence. Okay, so you need to find a confidence level to find Z alpha over 2. That's all. 3. Because you need a confidence level in order to find the critical what? Value. So this is the critical what? Value. Beautiful. Alright. So critical value instead of a bracket. Alright, let's move on. So now the third part is where you find the margin error. Alright, where you find the margin error. which is z alpha over 2 square root of b hat times the q hat. All this over what? N. Alright, so after getting this, that, then that. Because once you know this is easy. Once you know this is easy. That's all. Alright, so let's go to the last part for that is the confidence interval. The confidence interval. So now, the confidence interval is like this. We are using, don't forget that we are using the point estimate. We are using the okay. Alright, so now confidence interval. So that's going to be, let's say, the population being less than the point estimate plus the margin of error. Alright. So this one will be the upper bound. Then we can get the lower bound to be b hat minus what? The error. So error will come in. So now with this, you can now use it to estimate the what? The population. Alright. Good. So in other words, or you can also you can also write it in this way: b hat plus or minus e. And you are done with it. Alright. So that's that. So I'll be back for us to use all the idea we have discussed here to solve a question. And you trust me, you will love it. Don't forget, if you don't understand any concept, make sure you go back and revisit it again. In case, let's say you have a problem in reading your critical value, don't forget. Don't worry. When we are solving a question like this, I will take my time and bring the sheets closer and closer for you to see what is going on in getting it, so that in case you are not given an alpha level of these common ones that we have identified here, and let's say you are doing something like 85% and others, you should be able to do it. Thank you.